Okay, let us go ahead and get this started. So let us get going for today. Thank you all for joining us and finding a way to connect to us online so we can go ahead and keep the class going, even though I'm not able to be there on the Stanford campus today. Today we're going to do several different exciting things. We're going to really continue to build our facility with using some of the capabilities in Dynamo and actually learn some very exciting things about how we can actually use these visual scripting and programming environments to start controlling real building elements. So BIM model objects, going through and being able to kind of drive them through the scripting language. And we have several interesting examples to share with you that are really going to help kind of take us in that direction. Okay, so I'm just looking over to see if there's any more comments, or I think we're just about ready to get going. Okay, what I'm going to do is just to kind of conserve bandwidth and make it a little bit better. I'm going to hide my video camera, but at any time, if you have questions or whatever, just either type something in or jump in, unmute yourself, either way, so we can kind of have the conversation, still be interactive, even though we're remote. So I'm going to stop sharing my webcam. Okay, and what I'm going to start doing instead is sharing my screen. And hopefully now you should be coming up on your screen with the same thing that I am looking at, which is just a big mind map of what we want to talk about today. And Raj, if you or just anyone could type in to confirm that yes, you are indeed seeing it, that'll give me a little bit of a clue so we can kind of keep on going. So either just type it in the chat window, or if anyone wants to just unmute for a second. Okay, beautiful. Thank you. Okay, so it looks like we're ready to go. So in terms of what we're doing today, let me just go ahead and we'll skip past some of the initial stuff about the class structure and really just do a little brief recap about some of the stuff we looked at last time, some of the important lessons that we're going to continue to draw upon and continue with today. And they're involving things like, for example, let's think about Dynamo and just some of the very simple level, some of the high level things that we'll sort of be building upon today, just to refresh. So one is the whole notion of there is a Dynamo environment, okay, a visual programming environment, and there's a couple different nodes to it. There's a background as well as a node layout, which is on top of that. And just to get started, let me go through and just open up Dynamo. Come back over here. See what's going on there. What I'm going to do is open up the Revit environment. Dynamo is really an extension that exists either on top of Revit or on top of Visari. It's the same underlying engine either way, and there's an extension to be installed. Okay, we can give you the URL for that, or so people can download that. It's a pretty simple install. But let me just open up a basic Revit architecture project and show you where that is. And if you want to do that too, please do, because we're going to open up a lot of different examples. Actually, for today's classes we're getting going, if you go to coursework and download from the session 2 folder, you'll see there's actually a bunch of little files, or there's a zip file full of a lot of different examples that we're going to be using today. So that would be a very useful thing for you to have up. So if you can, just go to coursework in the background as I'm reviewing this stuff, and we'll get going. Okay, so in the architecture template, you can really do it from any of the templates. I'm just opening up a blank project file. The big idea is that we have all sorts of elements we can be placing in the modeling environment, and then we also have this ability to script on top of the modeling environment to go ahead and make things happen more programmatically, so we can start really quickly playing with different parameters and testing different aspects of the model to be able to really quickly identify, just evaluate and ultimately optimize based on them. So where Dynamo lives on the add-ins tab, and you'll find under the add-ins there's visual programming, and Dynamo comes up as its own separate window. And the way the Dynamo window works is there is a series of different nodes that are available in the library over on the left-hand side, and there's a 3D background view. And the big things to kind of really know about are that for any specific thing we want to do, what I tend to do is just type in some sort of a node name, like for example, I want to use some number. I click on that, and it creates a node that I can use. Let me go ahead and do just a few more of them. A quickie way of getting many different nodes is to just copy and paste. So I just Control-C, Control-V there. So I'm just really creating several different number nodes, again, just by copying and pasting. And out of that, I can go through and just go through, and I'm going to create a point. The If I link these together, it's going to be at the origin, 0, 0, 0. And now if I say run, or run automatically, if I want to do automatically in the background, you'll see I have a point kind of hanging around there at the 0, 0, 0 point. And I could change that. If, for example, I wanted to go through and have it be 5 off of the origin, I just type a value in there and you see the point jumps. So the important things right up front to know about. I'm working in a class right now. I'll be joining as soon as the class is up. Okay, so what is going on here is we can go through and rename any of these nodes. For example, I can go through and rename that to be origin point. And that's just giving it a convenient name. Okay, I can also go through and manipulate that environment in the background. And to do that, what I can do is, if I say under the background 3D preview, I can show the background 3D preview. I can turn that on or off depending if I want to see that, but we'll leave it on for right now. And then let me go through and say that we're going to navigate around it. Control G is the easiest way to do that. It now put up these little, the little icon which indicates the axes for the background view. And now I can orbit around there or zoom in and zoom out, kind of using kind of typical Revit mouse navigation commands. So that's just the basic environment. And we just want to get some of that stuff out in the background. So building upon that, let me go back over here. There's this whole notion of the background view in the node layout. We can copy and paste, right-click to rename. We drag things together to go ahead and connect them. Ultimately, click the Run button to automatically go through and execute those things to have the script evaluated. Let me pause there, see if there was a question. Nope. Okay, very good. Then there's some specific things we can do about creating all sorts of different elements that are part of the scripting language. Things like the number node or number slider, depending upon if we want to put numbers in and use them as inputs. So either inputting a single number or sliding to go through and control a range of values and move quickly between them. There's things for creating arrays and lists like number sequence or number range that allow us to create an array, either sort of indicating a step amount or the start and finish, and how many steps should be between that range, or the bounds of that range. There's also some nice arithmetic functions for adding, subtracting, multiplying, and dividing. Okay, and we're going to be working with all those things a little bit today as we go through and try and illustrate some different examples. So points, I just gave it a point right there, and we're going to talk a little about how we put lines through points. Okay, and those are just all different nodes that are available as primitives. Okay, yes, Raj, the meeting is being recorded, so hopefully we'll be in good shape there. Okay, so let me pause there for just a second, see if there's any questions about that introductory stuff and just getting started. Okay, no questions so far? Okay, oh, there we go. Nothing so far. Very good. Okay, then let us go ahead and continue to extend this a little bit. In last session's videos, in last session's class, what we did was we actually started just putting some basic points in place and started talking about how to control them mathematically, how we can actually start using math to control the relationship between the x, y, and z values in those points. And that's all useful enough in terms of getting started. A lot of what we do ultimately starts with the notion of just manipulating points and hooking geometry through those points. But we're going to push that a little bit further today. And today what we want to talk about is actually all sorts of stuff that involves really how we go through and just use the logic that we can set up in the Dynamo environment to go through and start controlling real Revit objects and actually controlling the parameters of those objects. So I have a series of different examples to work through that'll hopefully kind of start building this up in terms of thinking about that. Okay, so that's the game plan for today. So any questions as we get going? And again, anyone has questions, just feel free to type them on in there. Okay, and What we'll start with is sort of a pretty simple example. It's what I'll call an attractor, but it actually demonstrates sort of a really useful programming principle. And the idea here is really that we have two different points, or we have a series of points. We have a grid of points, which are affected by a very special point, which we call the attractor. And as the attractor moves around relative to the points in the grid, it affects the behavior of those points in the grid. So what we're going to do is actually go through and compute some sort of an attraction force based on the notion of the distance between the attractor point and the other points in the grid. And then based on that force, we're going to give ourselves some visual feedback to get a sense of how big the attraction is. In this case, in this example, what we're going to do is actually have a circle, which its radius is going to adjust based upon, like the strength of the attraction, which is determined by the distance away from the attractor point. So let me just demonstrate that, and from that we can actually, just see how it all works and is architected, so you can build a similar example. So to do that, what I'm going to do is I'm going to close up this simple point example and open up a different one. And what I'm going to do is open up, if I go to the 120C folder in session 2, this should be the thing that you've downloaded. Okay, the session 2 Dynamo examples is the folder full of them. And in there, the one that I want to go through and take a look at, oops, I'm in the wrong space right now. Right now I'm just looking at the Revit environment, so I'd be opening up a Revit file. What I want to do is reopen the Dynamo environment. I'm going to open from within that. So I'll be opening. Again, we'll go out to that folder, go to session 2, and let me find this whole notion of the attractor circles. Now, for all these different examples we're looking at, I've included two different files, an endpoint file as well as a starting point file. So the endpoint file is the finished script, okay, with all the pieces working. Starting point is what we use to actually build up from scratch. But let me just show you what the endpoint of this one looks like. So I'll say end. Okay, let me go ahead and pan this around a little bit. There's a system of logic up there that will build up in just a moment, but let me just try running to show you what we basically are looking at. So the idea is as follows. We have a big grid, okay, with a lot of different circles on it right now with varying radiuses. And what happens is we have a point which is controlled by a couple sliders. And the idea is as we go through and move these sliders, okay, let me turn on run automatically because that'll make it respond as opposed to every time I click the run button. As I move the sliders, you'll see the size of the circles is going to change based on the proximity. There's the little attractor point. You can see it now. So basically, when things are very close to the attractor point, okay, they're a very, very small radius. When things are far away, the distance is greater, the radius is getting much larger. And that's the basic logic we're trying to build here. Okay. Here, what we're doing is just controlling the size of these circles, but we're going to see in just a few minutes how this is actually used to actually control parameters, instance parameters, or type parameters for Revit objects. Okay, so as we look at this and the basic logic, again, let me kind of zoom back in again. The idea is that we can move the sliders around. Okay, and as we move the sliders around and the point moves around, it's moving those objects, the radius, moving or affecting the circle radiuses. Okay, let's go ahead and start building that up and just kind of use that as an example for understanding about how we can link together some of these networks. And to do that, what I'm going to do is go to the other file, 2.1, the attractor logic circles with the starting point, and bring up a slightly different kind of version of this. And let's see if we can sort of see how this works. And please go ahead and follow along if you can. The idea is it's all starting out with this notion of creating just an XYZ point grid. This is the grid where all the different circles are hosted. It's the origin point of all the different circles. Okay? And from that, okay, we have a number of different things. What we're doing in the XYZ grid is we have some points. 15 is driving the X count and the Y count, so it's going to go through and create points at every 15 points in the x direction, 15 points in the y direction. In the z direction, it's only 1. The x0, y0, z0 is just the starting point, so starting at 0, 0, 0 as we build an array out. And the spacing is basically 2 by 2. So it's going to go from 0 to 30 and 0 to 30 in both the x and y direction. The other kind of key piece of this is this notion of an attractor point, which has x, y, and z coordinates. And you'll see we've set up some sliders here that vary it from 0 to 30 in both the x and y direction, but we keep it down at z right now. We're keeping that currently, okay, just hanging there right at 0. So it's going to be down on the floor. So what we want to do is actually go through and start thinking about the distance between all of the different points in the grid and the attractor point. Okay, the XYZ distance is actually a function that's built right in, so we can go ahead and just type it in there, XYZ distance. And you can find it and add a new note, or I already have one of them in there for you. And the way the relationship works is we can take all the points in this list, and what I'm going to do is just connect from all the points in that list and the attractor point location. Okay, and it's going to compute a series of distances. And if you even want to sort of see what those distances are, you can see there's a whole list of, those are the distances from all of the different points in the grid, okay, to wherever the attractor point is right now. And if we would go through and change the position of the attractor point, that list would change. The distances would change in terms of how far away they are, how close they are. Okay. So based on that, we could go through and put together a whole bunch of circles, okay, that are all based on the notion of just really, how far that distance is. The radius is based on that. So to do something like that, we can go through and just type in circle. We put that node in there. Okay. We want to create a whole series of circles, and what we'll do is we'll create the centers as being all the grid points. Okay. And for the radiuses, let's go ahead and take that XYZ distance. And you'll see that what we have is a bunch of very large circles. Because as the radius goes of all these different circles from that point, if we take the distance, we have a bunch of circles which are really almost as big as the grid. But you can go through and see, if you move the attractor point around, the locus or they all sort of move. The focuses of all that kind of move around a little bit. Okay. But this gets us pretty far. But let me just pause there for a second on this whole notion of kind of linking all these different distances together and creating a series of circles. And see how that feels. Any questions about that so far? Because that's really a very basic operation, but it's a really good starting point. Just to say we have all these things, we're going to compute a distance, and ultimately then use it to drive some sort of geometry, in this case the radius of those circles. Okay, so far so good? If that's feeling pretty good, the next step we might want to do in terms of enhancing this is, those circles are a little bit big right now. So let me go through and adjust those. And to do that, what I wanted to do is just sort of put a scaling factor on the XYZ distance. So as opposed to using the full distance as the radius, just say, what if instead we took those and we divided it by a number, just to scale it down, and instead use the result of that division as the radius. And that just makes it a little bit better, a little bit easier to kind of deal with in terms of seeing it visually. Another thing we could do if we wanted to, yes, is there a question? Yeah. At this point, you can see that if you do start playing with the sliders, the circles are resizing themselves. We can do all sorts of things, like we can say, let me do a slider. if as opposed to sort of putting in a hard value, we actually want to say, oh, let me vary that anywhere from 0 to 30, I could put that in as opposed to putting the hard value in there. And that would then give me the ability to kind of scale these circles. But the fundamental notion that the logic is holding together, and it's based on moving that point, that's really the point of this example, is really to say that we can do some calculations, and based out of that calculation, we can start controlling some geometry. In this case, very simple geometry, just those circles. Okay, but we're going to extend that in just a minute to say, what if we actually control the geometry of some Revit objects instead? Okay, so let me pause there for a second and just give people a chance to sort of ask questions or kind of catch up if you're trying to follow along. So Raj, let me check with you. What's your sense in the room in terms of are people sort of comfortable with that? Or do you need a chance to kind of just play along for a few minutes and sort of see if they can make that happen too? Okay, very good. Okay, so that's building the whole notion of just a network of logic that's going to go through and just drive a little bit of action in terms of the geometry. Let's go ahead and extend that a little bit further, though, and say, how can we actually use this to start controlling Revit geometry? And we're going to go to a slightly different example, but one that's very closely related, and that's what I'm going to call attractor cubes. And in the data sets that are there, you'll find that as example 2.2. Within this, we're pretty much doing a similar thing. We have the attractor, we're going to move a point around, it's going to look like very simple, very similar logic. But what's going to happen is, opposed to going through and just adjusting the radius of the circle, now we're going to want to try and use that distance to actually set the properties of a Revit family. Okay? And in terms of that, the basic things we're going to do are we're going to create some Revit families at the grid locations. So as opposed to putting just X, Y, Z points at those locations, we're going to create different instances of a little box family. How do you write comments? Very good. Let me see if we can do that. Actually, let me finish this, and then we'll show you back over there too. Then after we go through and create the Revit families, then we're going to learn how to set the parameter values, both family parameters as well as family type parameters as well as instance parameters. Okay, so let's go back over and let's open up a different example. Actually, even in here, so I can sort of answer the question here. Another element is, let me see if I can find it in here, because I don't do it too often. It is create note. So when you want to go through and put comments in the interface, you can say under the edit menu, create note, and it just kind of throws that in there. And then this is a comment to help explain the logic. So go ahead and think of them as just like sticky notes that you can embed anywhere you want to help explain the logic. And it's a very, very good practice to go through and embed lots of comments, because you can imagine as these networks get to be very large and the network gets, all the logic gets to be much more complicated, it's useful to embed these things to help explain things later, what you were thinking, because it's always good to read comments as you're doing any sort of programming. Okay, let me open a slightly different one. And the one we're going to open this time, I'm going to open this attractor cubes, change parameters end, just to give you a sense of what it looks like. Actually, I'm going to take that back. This is one, since it actually works within a family, what I need to do is open the Revit file that includes the family first, and then I can do the logic that affects the family. So change plans a little bit. I'm instead going to close Dynamo and open Revit, and within Revit, go through and open, there's a file in there. Oh, I'm looking at the zip file. There we go. Try creating, open one that says example 2.2, attractor cubes placed. And you will see that this file, it's not all that different. A lot of flashing on my screen as it opens up. We zoom on in there a little bit so you can see. This is just a series of different Revit objects. These are all little Revit families where if you click on any of them, you can actually see it has different both type parameters and instance parameters. The instance parameters are width and length. The type parameter is actually the height. Okay, but basically we're going to be driving the behavior of these cubes based on this notion of the tractor again. So we have all these different ones. We could go through and type in the values individually that we want to have associated with all these different boxes, or we can let the programming language do that for us. And how we would do that is we'll say, let's go to the add-ins and open up a Dynamo script which determines these things. So then you kind of pull it over there a little bit. So in terms of that script, let's open up now the script that's associated with this one. And it's called attractor cubes. Let me do the parameters end. And let's see if we can just sort of unpack its behavior a little bit so you can sort of see where this is going. In many ways, this is very similar to what we did before. There's a grid that we're setting up, and there's an attractor point that we're setting up. But now, as opposed to putting X, Y, Z's on the grid, what we're going to do is actually create a family called box shape resizable. And we'll place those at the grids. And then we're going to go through, start basically adjusting the instance parameters, both the width and the length, kind of based on the distance calculation. Okay, so let me just show you what that looks like, and then we'll go ahead and build ourselves back up towards it. So, I'm going to pan this around just so I can sort of focus on that slider. I'm going to say run automatically if I want it to sort of respond immediately. And there's a choice there about whether you want it to sort of move continuously as you move the sliders or only at discrete increments. Okay. So what happens now is as I move the slider, it's doing a lot of calculating in the background, because it really has to go through and resize all these slots, or all these boxes. And as I've moved it, it's actually kind of shifted the values a little bit. If you go clicking on any of these, you can actually see its computed values. So far out here, it's 8 feet. You know, here in the middle, it's like 1'2". In the same sort of sense, if I would slide that way over, this is actually probably a pretty good example of why I might not want to continuously update and run automatically. I might just want to do this as snapshots after I kind of choose different values. Okay, and we moved it some. Let me do this. I'm going to turn off run automatically. Drag that way over. And then click run. Which will probably be a little bit fairer in terms of giving us a snapshot where you can actually see the difference. You can see now it's regenerating all those points based on the new values. Okay, and now it's way over in the far left corner in terms of where the attractor point is, as well as where the action is. Okay, so let's go ahead and talk about how we can build this up. Actually, let me just sort of pause there for a second and see, are there any questions about sort of what we're after? It's sort of the same notion of the attractor point, but now we want to be driving geometry instead. So let's see how that resonates with people. Okay, if you are ready to tackle that one, let's go ahead and get going. What we're going to do is open up a slightly different script file. So as opposed to that existing one that's all fleshed out, let's go to the starting point. And I've already set up some things for you, but we'll sort of fill in the gaps. So let's kind of just zoom on in and see if we can make sense of this. In the same sense as what we were doing before, we have this XYZ grid. Super. So we set that up. It looks like it's going to go, what is it? We're going to have 9 points, so 9 different cubes in both the X and Y direction, only one tall, so one in the Z direction. It's starting at 0, 0, 0. That's the XYZ 0 point. And what the spacing is, every grid point, every box will basically be 10 units away from the other one. So we're sort of setting up a grid 9 by 9, 10 units in each direction. Okay. We also have this attractor, so we're going to have some sort of a point where, in this case, X and Y are both tied to a single value, so it's, we're dragging a single slider, it's moving in both the X and Y direction. But again, it doesn't have to be. We can sort of go through and kind of separate those if we want to. The Z value is at 0, it's keeping it down on the ground. And what we're doing is computing a distance, the distance between the attractor point and the grid, and dividing it just by a scaling factor. So that's just exactly what we did in the last one. Nothing different there. What's going to be different, though, is we're going to use this thing called select family. And select family lets us go through and choose of the different type or families that are loaded into our project, the one that we want to go through and create. So if you pull down on that, you can see that it's actually going to give you a list of all the different families that are available, that are currently loaded in the project. These are loaded things. So if it isn't loaded into the project, it won't be available there. Okay, so where can I find it here? Again, what did I call that? It's like box-shaped resizable. There it is. That's the family we're going to be adjusting. What I'm going to do is basically use another function called create family instance. And so given a family, it'll create an instance of that. Okay, and how that works is, let's see what's going on there. Any question there? Okay, few questions to answer. Are Revit and Dynamo interfaces automatically connected? The way it works is the Dynamo is an add-in to Revit. So what do I want to say in terms of interfaces? Dynamo sort of lives within the Revit environment. Okay, and if you have a Dynamo script that you've created and opened within a Revit file, it then gives you access to the Revit objects in that file. And second, do we need to save the files separately? From the standpoint of any action that you would like to script and run, they should be in separate scripting files. Okay, so if we had several different things going on, basically every time you hit the run, all the scripting on that one script file is going to be executed. So to the extent you want to be able to separate those and do different things, like for a single Revit project, you might have 4 or 5 different scripts that do different things, and they put them in different scripting files. They could be in the same Revit file, though. And so you could have as many Dynamo scripts as you want per Revit file, each one carrying out different actions. Hopefully that'll make some sense. So let's show you how this works. Close up some alerts just so they're not bothering us in the corner there. Okay, in terms of linking the logic together here, here's how it basically works. Create family instance basically wants some sort of a type of a family. Okay, then it wants a location to put it. So what we're going to do is link that piece in. So, but to do that, what I'm going to do is just link these XYZ points. Okay, let me see if I can scoot that over a little bit so you can see that. So I'm going to get these XYZ points and link them in as the location. Okay, and that's actually enough to get started. Just even at that point, if I would say run, interesting. Oh, that's just showing in the preview view. you'll see, what's interesting at this point, well, the instance parameters, they already exist, the instance parameters are still the old ones. So I guess we still need to do a little more to kind of make that actually change. If I'd started with a fresh file, and that would be completely blank right now. So what we want to do is thinking about, great, we've created a bunch of these different objects. Let's think about now how to go through and set some instance parameters based on those. For all these different family instances, this 9x9 grid of all these instances, you basically have the notion of, you basically can link a family instance to something that's going to connect to the instance parameter. Okay. Then you basically have to say what instance parameter you want to connect it to. And that's actually just a string. So for example, if I type in string here, and I want to be changing the value, for example, the width or the length, I can just type that in there and link that together. Oops, not value. It goes to the parameter. If you want to get rid of a link, what I often do is just going to click on the label again and then escape and remove that link. Then we can put a value in there. And for the value, we could go ahead and put a number in there. For example, if I put a value of 5 in there, okay, I'm basically now going to create a whole bunch of boxes that all have what the width of 5. So if I would run that, let's see what's going on in the background when it finishes regenerating. So I'm expecting to see a whole bunch of boxes back over there that all have a width of 5. Okay, so currently they all have that width of 5. Orbit that around a little bit, you can see better. They're all uniformly wide. We could also go through and create an instance parameter. I can just copy and duplicate that if I want to. Okay. But this time, I'm going to go through and create a string to refer to another parameter. And put another value in there. Okay. For this other parameter, let's go ahead and say instead of the width, we want to control the length of the boxes. I could put something else in there. Okay, this would be creating a bunch of 5x2 boxes now. Okay, and that's kind of okay if that's what we want to have happen. Let me warn you in terms of putting in these parameters, it is very sensitive to the name. So if it says width over here, make sure it really is width. Watch out for this. I made this mistake at first myself. If you put, for example, a carriage return in there, it may or may not recognize it. Okay, it's complaining right now because it couldn't find width return. Okay, so what I got to do is just take it back, and if you're getting an error like that, it is just that it's but it needs to be a very precise match for whatever the label is. So it's a bunch of 5x2 boxes. Now, that was kind of okay in terms of what we wanted to get started with, but it's not really where we wanted it to be. What we've decided is that we would really like to have this whole notion of the attractor force determine the length and width, okay, of all those different boxes. And to go from where we are now to making that attractor force do that, it's actually pretty straightforward. All we have to do is as follows. We have the attractor force computed just kind of right over here based on the length between the grid points and the attractor point. We put a little scaling factor in there. So this is really the strength of the attractor force right now. So if I want that to be the parameter, okay, then what I have to do is basically link from, what I'm doing is I'm hitting the escape key to move from the panning mode to the linking mode. and I'll make that the value here as opposed to a fixed number. And I'll make that the value here as opposed to a fixed number. Now, you'll notice I now have some loose nodes hanging around that aren't really doing anything, and that's okay. Those loose nodes can hang around and not do anything. Maybe I'll use them again later. Okay. But the ones that are linked are the ones that are actually doing something. So if I do this now, and I say run, what I am hoping is going to happen in the background there is when this all regenerates, is that the grid of all those boxes are all going to have values that kind of appropriately reflect, that notion of the string. And there we go. So, and now as I go through and move that point around, hopefully they'll all update themselves accordingly. Okay, let's let that run in the background. Okay, now it's moving over there. So we've just started then to go ahead and have this notion of the ability to go through and control these different instance parameters, or we could also go through and create control type parameters too. There's another node type, and it's called a set family type parameter, and I can go through and tie some of these things together. So for example, if I wanted to go through and control the height attribute also of all these boxes, I could, for example, oops, I just want to move that one. I'm going to put height in as the parameter that we're going to control. Oops, wrong one. I need to go through and get the family type connected in there, and then I can put in some value. Maybe I'll just borrow this node, and I'll say that I want to make them all 10 tall. Okay. Or if we wanted to, we could go ahead and make their height be related to, again, the strength of that parameter. So for example, if as opposed to having them all be 10 tall, if I wanted them to be related to the attractor, maybe I could go ahead and tie that one in there too. Okay, and let's see what that actually looks like. I expect that'll create some sort of a crater. Or a mountain. I gotta think about that for just a second. Oh, actually, I'm going to correct myself there. Actually, I don't expect this is going to have much of an impact, because as a type parameter, I think all the ones are going to basically have the same type. What I would need to do is, I think if I wanted to have the cratering behavior, let me see if it really does. Yep, they're all still essentially the same height in terms of what's going on. If I wanted to have more of that cratering behavior, what I would need to do is, I'll just do it as long as we're in here. Again, this is just for folks who want to play along. I could take that and I can edit the family. And what I'm going to do is just change its parameters around. So as opposed to the height being a type parameter, I can say I want that to be an instance parameter. So what is the advantage of doing this? The only reason we do this, or the only advantage to doing this, is that it will then allow us to change the height of those independently. So with that little piece in place, let's let that finish loading. What I could do is, it won't be a type parameter, it's going to be an instance parameter instead. Get rid of that node. And I'll say instance, set family instance parameter. So again, what do I need to do? I need to link in the instance. I need to link in the height as a value. And then this is the strength of the attractor right there. Let's try that. Okay. It's a working. Let's see how I take. Okay. So now down in the corner, it's very, very small on the height. If I moved it around, it would crater. So it looks like it's based on where the attractor is, we'll go ahead and have it's almost like a sphere collided with it and is pushing mass out of the way. Okay. Okay. So you can't find, okay, so Pablo says, I can't find the box-shaped resizable family. Is there any way to load in families? And yes, there is. So if you started with a brand new project, okay, and that family is not already loaded, what we have to do is just back over in the Revit project, okay, over here, say insert, and load the family. And then within that, if you go to that same folder, I left the file, it's right out there, this box size shape. So if you import that, so just load it into the family the way you would do any sort of Revit library object, okay, then it'll be available for you in that pull down. Okay, so once you put it in there, it's available in the same way I can almost do that with anything. So for example, if I came through and loaded in 5-door lateral file cabinets or something like that, what will happen then is over here, with any luck, 5-door lateral file cabinets are over there. Let's pause there for a second. Let's just sort of get a sense of this in terms of, this fundamental notion of being able to change instance parameters or type parameters is really, it's so basic to what we're going to be doing from here on out. So I just want to hang there for a second and give people a chance to ask questions about that, or just kind of think about really, what that means. And I'll keep on pushing that basic example, but it all really starts with this notion of being able to take the math and let it drive the instance parameters and the type parameters with different objects. So Raj, if you can kind of get a sense of the room and how people are feeling, and just let me know sort of either if there's some questions or if people are ready to move on or just what they'd like to do.